Hello everyone, in this video we are going to discuss about ABG, arterial blood gas analysis. Before starting this topic, let's learn about the anatomy of our upper extremity. We have radial artery, ulnar artery. The radial artery goes through the thumb and make the arch, and the ulnar artery goes to the ulnar part of the hand and make the arch. The most common site for taking arterial blood is radial artery. Before taking the blood sample, we do one test which is called modified Allen test. In this, we ask patient to make the fist of his hand, and we press the radial artery and the ulnar artery, and for sometimes we left the ulnar artery and look for the any change that occurs in the hand. We wait for 5 to 15 seconds. If the hand is normal, then we have the patent ulnar artery, so we can now proceed with the radial artery sampling. It is given here. So why we do arterial blood gas analysis? For seeing the oxygenation, ventilation and some acid base disorders. The procedure is as I explained sometimes ago. We have to take the informed written consent before doing these procedures. We have to explain possible complications like infections, trauma and so many things, and we should look for the contraindications. If there is the Allen test is negative or there is infections in the hand, then we should withhold the procedure. Traditionally we know the formula, it's called ROME. If the pH is decreasing and PCO2 is increasing, so respiratory opposite metabolic equal means it becomes respiratory acidosis. But if the metabolic equal means if the pH is also dropping and HCO3 is also dropping, then it becomes metabolic acidosis. But in this video we are going to learn some more than that. Typically in our hospital we get such kinds of report and we have to interpret what happens to the patients. So as we get this report, first we should check the value of the PO2, partial pressure of oxygens. In this patient we have 77, normal is more than 65 up to the 105, PO2 is 77, and next we have to check his PCO2. PCO2 is 35. These both are in normal range. Third, we should check his pH. It's 7.25. 7.25. It is reducing. Normal is 7.35 to 7.45, and HCO3 is 19. Normal is 22 to 26. It is also in decreasing. If pH drops and HCO3 also drops, according to our formula, metabolic in the same side. So most probably it is metabolic acidosis. Once we diagnose the case it is metabolic acidosis, we should check the anion gap. Either it is high or normal. It's called AGMA, HAGMA, high anion gap metabolic acidosis, or NOGMA, NAGMA. For this we have the formula sodium minus chloride plus bicarbonate. In this we have sodium of 140, chloride of 107, and bicarbonate of, where is bicarbonate, 14. It becomes almost 14. So this, using the formula we get our actual anion gap, but we have to see the expected anion gap. The expected anion gap in this case is 12. This is formula, change in pH plus albumin. In this we don't have albumin, so we neglect this value. Change in pH, the pH is 7.25. The actual normal pH is 7.35, so there is drop in 1, 7.35 to 7.25. So we have to deduct 2 from there. So 12 minus 2, around 10. So the N actual is greater than expected, so it is our high anion gap metabolic acidosis. We can see some cause of the HAGMA, HAGMA. It is called cat, mud piles, aspirin, carbon monoxide, cyanide, caffeine, acetaminophen, theophylline, methanol, metformin, uremia, diabetic ketoacidosis, propylene glycol, isoniazide, ibuprofen, iron, lactic acidosis or ethylene glycol. After this, we have to see for corrected bicarbonate level as well, as in some cases there might be some hidden disorders. So its formula is delta anion gap plus bicarbonate. The delta means 14 minus 10, it's 4, and bicarbonate is 19, it's 23. The correct bicarbonate is in within normal limit, so there is no any hidden disorders. So in case of metabolic acidosis, we can use Winter's formula and see the expected PCO2 using 1.5 into serum bicarbonate plus 8 plus minus 2, it's become almost 35, so it's normal. So there is no any compensations or mixed disorders. Now let's discuss about FiO2. FiO2 means fractions of inspired oxygens. In normal air, room air, the FiO2 is 21%, but if we give patient 1 liter oxygen, it becomes 24. If 2 liter, 28. If 3 liter, 32. If 4 liter, 36. And if 5 liter, 40. We can memorize, we add 4 in every steps. 24 plus 28 plus 4, 22 plus 4, 36 plus 4, 40. But in case of if we keep the patient in ventilations or some things, it becomes about 60 to 70%. This level we can see in our ventilation machine. So we have to calculate the AA gradient to see there is actual problem in lungs or not. So if for calculation of the AA gradient, we have formula 713 minus FiO into FiO2 minus 1.25 into PCO2 minus FPO2. Its normal range is 15 to 50. If it is more than 50, then there is lung problem like ARDS. So it is the shortcuts or some causes for our metabolic disorders and respiratory disorders. You can see this table yourself. Thank you.